ever wondered what serverless computing really means? Is it truly serverless? Why is everyone from startups to enterprises jumping on this trend? In this video, we are breaking it all down. What serverless is, why it matters, and how it works behind the scenes. Whether you're a beginner or brushing up on cloud concepts, you are in the right place. By the end of this video, you will know when to use serverless, what tools to explore, and even some real world use cases to inspire your next project. What is serverless? Serverless doesn't mean there are no servers. It means you don't manage them. In a serverless model, the cloud provider handles all the infrastructure, provisioning, scaling, patching, and even turning it off when it's not needed. As a developer, you write business logic, upload your function, and the cloud takes care of the rest. Think of it like ordering food instead of cooking it. Focus on the meal, not the kitchen. Why serverless? Why go serverless? Because it's faster, cheaper, and smarter for modern apps. No infrastructure management, auto scaling, pay only when code runs, faster time to market. It's perfect for teams that want to move fast without managing the heavy machinery underneath. How serverless works. Here's how it works behind the scenes. You deploy your code as a function when an event triggers it, maybe an HTTP request, a file upload, or a message in a queue. The cloud provider, this is what happens, spins up a container, runs the function, automatically scales, and shuts it down when it's done. All this happens in seconds thanks to container orchestration and smart scheduling. Here we have triggers and event sources. These are the things that start the entire serverless workflow. We have HTTP request when a user makes a request like clicking a button or on a website or calling an API. And when a new file upload, like when a new file is uploaded, for example, to AWS X3 or Azure Blob Storage. And an event, when a system event occurs, like a message published to PubSub or an event posted to EventBridge. These are external events that activate the system. The input that tells your serverless system to run. Then we have API gateway or the event bus, which is the entry point. This is the controller or the gatekeeper that receives those events and determines where to send them next. API gateway is used for HTTP based triggers like web requests. It acts like a friend door that accepts incoming API calls. Event bus, example EventBridge, is used for asynchronous or event-based workflows. It routes different kinds of system-generated events to the correct service. This component ensures that events are properly received and directed to the correct logic block. Then we have the serverless function, which is the core logic. This is where the actual processing happens. The function as a service platform. Example, AWS Lambda, Azure function, and Google Cloud function. The Some of the characteristics of this serverless function are: it auto scales, it instantly adjusts how many instances are running based on demand. It is stateless, each function call is independent. No memory is saved between calls. And pay per use, you're only charged for the compute time used, not for the idle time. This is like the brain of the operation. It runs your code in response to each trigger. There are backend services that your serverless function interacts with, such as database for storing structured data, example user info, transaction logs, and storage for saving files, images, and documents, etc. And queue and notification service for messaging, background processing, or alerting users or other systems. These services provide persistence and communication support to your serverless application. Here we have the user or client app. This is the end user interface where your system outputs a result or delivers a response. The user might receive a confirmation, view processed data, or get notified via message. The client could be a web app, mobile app, or another system. This is where the results of the serverless processing are made visible or useful to the user. This layered system is what makes serverless architectures highly flexible, scalable, and cost efficient, especially for modern applications that require agility and event driven responses. Scalability and efficiency. Serverless apps scale horizontally, meaning more instances spin up instantly when traffic increases. Got unpredictable or spiky workloads? No problem. Serverless handles it gracefully without you configuring auto-scaling groups or worrying about load balancers. Pricing model: you are billed for what you use, literally. You pay based on number of invocations, memory, and duration, and that's it. No charge when idle. This makes it perfect for low frequency jobs or unpredictable traffic patterns. Use cases. What you can build with serverless. Here are some popular use cases: REST APIs with API Gateway and Lambda, ETL and data pipelines, IoT backends, real-time file processing like image resizing, chatbots, cron jobs, and microservices, CI/CD automation, and alerting workflows. If it reacts to an event, you can probably build it serverless. Popular tools and frameworks. Let's look at the tools empowering this revolution. The major platforms are AWS Lambda, Azure Functions, Google Cloud Functions, IBM Cloud Functions. At the edge, we have Cloudflare Workers and Vercel and Netlify Functions. And for Kubernetes, we have OpenFaaS and Knative. These tools let you run serverless on public cloud or on prem. Complementary services. Serverless works best when paired with other managed services. Examples: API gateway for triggering functions via HTTP, and S3 blob storage for triggers on file uploads, and Event Bridge and PubSub for event handling, DynamoDB Firebase for scalable data storage, SQS, and Kafka for queue-based architectures. Together, they form a fully managed event-driven backend. Challenges and considerations. Serverless isn't perfect. Here are some common challenges. Cold starts. First invocation after idle can be slow. Timeout limits. Max duration, example 15 minutes on AWS. Stateless. You'll need external storage for state. Vendor lock-in. APIs are cloud specific. So always access your app's needs before choosing serverless. When to use or avoid serverless. Use it when you want fast development or deployment. Workloads are event driven or bursty. You need low cost automation. Avoid it when you need long running, high uptime apps. You require fine grained control over infrastructure. Your workload is compute heavy, like video rendering. That's a wrap on serverless computing. Now you know what it is, why it matters, how it works, and when to use it. If this video is helpful, please feel free to like, subscribe, and hit the notification.